Here is a quick example of how to calculate the standard deviation. First, let's talk about what standard deviation is. You can think about standard deviation as a measure of variability or spread in the data, okay? And then it's defined as the average distance the values of a variable are from the mean. And so what that means is that the further away the values of a variable are from the mean, the higher the standard deviation. So the larger the standard deviation, the higher the variability, meaning that our observations are more spread out and not clustered around the mean. So here is an example of how to calculate the standard deviation. So take 6 students, and let's say the height of the 6 students is 62, 72, 64, 67, 54, and 60. And we're asked to calculate the standard deviation of the height. So the first thing we want to do, step 1, is to write down the formula. And I will define term by term what this formula means. So standard deviation, which is S, is the square root of the variance, which is S squared. So the square root of the variance, and that is equal to, under the square root, 1 over n minus 1, where n is a sample size, multiplied by the sum of all the observations. So that's what this sigma I equals 1 to n means. It's the sum for all the observations, from the first observation I equals 1 to the nth, in this case n equals 6, of xi, which is each individual observation, minus x bar, which is a mean, all squared. And I will break that down in the example. But this is the standard deviation formula. So the next step, once you write down the formula, is to write down or calculate what you can actually know easily. So back to the formula for the standard deviation. We already know n, and that is equal to 6. And x bar is easily calculated because that's the mean. So x bar is the mean, which is the sum of all the individual observations divided by the total number of observations. So here we have 6 students, so n equals 6. And then the mean is then given by 62 plus 72 plus 64 plus 67 plus 54 plus 60 divided by 6. So again, we're summing up each of the individual observations and dividing by the total number of observations. So here, if you calculate this, you get x bar is 63.17. The next step is to figure out what you don't know. So back to the formula, we have figured out what n is, and we have figured out what x bar is. So now the next step is to find out or calculate what this entire term here works out to. So first, we know again n is 6. We know x bar is 63.17. And the easiest way I've found to calculate, to evaluate this term, the sigma I equals 1 to n of xi minus x bar all squared, is to put a table together. So on the left, we have all the observations from 1 to 6. Okay, so the first one is 62, the second one is 72, the third one is 64, 67, 54, and 60. And then the next thing we're going to do is to evaluate just this term here, xi minus x bar. And so that's right here. And then after that, we will then calculate the square term. So this whole term now xi minus x bar all squared. So taking the first observation, the value is 62. 62 minus x bar, which is 63.17, is negative 1.17. And then you square that number to get 1.3689. So remember, when you square a negative number, you end up with a positive number. So square of negative 1.17 is positive 1.3689. Next thing we want to do is the second observation, which is 72. So you do xi, 72, minus x bar, 63.17. That gives you 8.83. And you square that to get 77.9689. And you do that for each individual observation and square it. And that then allows you to calculate. And then once you sum up all these values here, then if you sum it up, you will get 188.8334, which is the sum of xi minus x bar all squared, which is the same as this term here. So once you have that number, 1.888, the number is 188.8334. Then the last step is to plug in your numbers into the formula. So n minus 1, you know what n is. So n minus 1 is 5, so that goes here. So s, again, equals the square root of 1 over 5 multiplied by this sum that we calculated here to be 188.34, and we can plug that back into the formula. So 188.8334 divided by 5, all under the square root, is 6.15. So again, you know what n minus 1 is, and that's 5. So 1 over 5 multiplied by the sum of all the observations from observation 1 to observation 6 of x minus x bar all squared, which is what we evaluated to be 188.8334. If you multiply that term, 1 over 5 times 188.8334, and you take the square root of that product, you end up with 6.15. And so finally, you can state your result that the standard deviation of the height of these 6 students is 6.15 inches.